The Numbeks System. Hi everyone, today I'll be sharing with you the historical background of the Numbeks System. The Numbeks System is actually a coined term that combines two words, Num, meaning number, and Beks, a Filipino slang for Becky or gay. This blend shows how it's both mathematical and deeply connected to queer cultural expressions. To trace its roots, we can look back at the long history of coded language in the Filipino LGBTQIA+ community. One of the most popular examples is Swardspeak or Becky's, a playful mix of Tagalog, English, Spanish, and pop culture references. For many years, this served as a tool for identity, creativity, and even discreet communication during times of stigma. The Numbeks System is a modern continuation of this tradition. Instead of just words, it gives new and playful meaning to numbers, transforming math into a cultural code. In doing so, it highlights the resilience and artistry of the LGBTQIA+ community, showing how even something universal like numbers can become a symbol of empowerment, pride, and belonging. So, the Numbeks System is more than just numbers. It's a reflection of wit, identity, and creativity of the Filipino LGBTQIA+ community. And now, let's proceed to the table of our elements. Here we can see the base 10, base 5, symbol, and the names of each symbols. Now let's look at base 5. For number 1, we have the symbol and the name Lumo. For number 2, we have the symbol and the name Flora. For number 3, we have the symbol and the name Nexo. For number 4, we have the symbol and the name Sura. And now let's look at the base 5 number 10. We have this symbol, and its name is Lumo Nava. It's a combination of Lumo, which is our number 1, and Nava is equals to number 0. Then so on and so forth. So basically, for the number 10 onwards, it's just a combination of the names of our single numbers. Ways of conversion from base 5 to base 10. So first on the list is the positional notation, and we are very familiar with this computation. So on our example, we have 12,431 base 5, and we're gonna convert it into base 10. So in positional notation, let's just remind ourselves that for us to remember what are the possible exponents that we're going to use, let's just count the number of our digits of our examples. And in here, we have 5 digits. Let's just subtract 1 so that we can start with 4 as our first exponent. So to solve this positional notation, let's bring down all of our digits or coefficients. Then we're gonna multiply it to our subscript, which is 5 because we're on base 5. Then for every coefficient starting from 1, we're gonna put an exponent of 4. Then for the next one, we're gonna put an exponent of 3. For the third one, exponent of 2. For the fourth one, exponent of 1. And for the last one, exponent of 0. Then let's just compute it. Then we're gonna arrive at the answer of 991. As simple as that. So next thing on the list is the synthetic division. And I'm not quite sure if everyone is familiar with this kind of computation, but I'm going to teach you how to solve this computation, and it's so easy. So first, we need to draw this two vertical lines and one horizontal line. Then let's put above our given number, which is the 12,431. Then we're gonna put our subscript on the left side because it is gonna be our divisor. So first, we need to bring down our first coefficient, which is the number 1. Then we're gonna multiply it to number 5, our divisor. And 5 times 1 is equals to 5. Now that we have number 5, we're gonna add our next coefficient into it. So 2 plus 5, we're gonna arrive at the number 7. So that's the process. And to continue, we're gonna multiply 7 to 5. Then we're gonna arrive at 35. 35 plus 4 is equals to 39. 39 plus 5 is equals to 195. And 195 plus 3 is equals to 198. 198 times 5 is equals to 990. And 990 plus 1 is equals to 991.
Now, Let's explore more about the Numbeks system with the discussion of an arithmetic demonstration, starting from the addition. In the symbolic system, each character represents a digit in base 5 and is associated with a unique name. For the first step, we can translate the symbols into their base 5 equivalents using the reference table. The first symbols that we can see is composed of Lumo and Cora, forming the base 5 number of 23. The second symbols that we can see consists of Nava and Cora, forming the base 5 number of 12. For the next step, we can convert these base 5 numbers into base 10, wherein 23 in base 5 is equals to 13, and 12 in base 5 is equals to 7 in base 10. Adding these two base 10 values give us 13 plus 7, which is equals to 20. Now, we can convert the sum or the 20 in base 10 back into the base 5. Dividing 20 by 5 gives us a quotient of 4 and a remainder of 0. And dividing 4 by 5 gives us a quotient of 0 and a remainder of 4, which results to 40 in base 5, also called as Sura Nava. For the second example, we have 32 in base 5, also known as Nexocora, and 14, which is Lumocora. Adding these two numbers together, we get a value of 101 in base 5, which can be called Lumo Nava Lumo. Now, let's go with the discussion of the subtraction. First, we can see 23 in base 5, which have the name of Cora Nexo in the Numbeks system. The subtrahend has the value of 12, which is called Lumocora in the Numbeks system. For this process, we just follow the standard subtraction system. Here, we can start by subtracting 2 or Cora in 3, also known as Nexo, giving us the value of 1, which is also called as Lumo. Then, we also subtract 1 or Lumo from 2, which is called Cora, giving us the value of Cora Lumo in the Numbeks system. For the next example of subtraction, we have Nexosura as the minuend and Lumo Nava as the subtrahend. Performing the operation, we subtract Nava from Sura, which gives us the value of Sura, and Nexo minus Lumo gives us the value of Cora. Therefore, Nexosura or 34 in base 5 minus Lumo Nava or 10 in base 5 yields the difference of 24 or Cora Sura in the Numbeks system. For the multiplication, let's start by discussing this example. Here, we have 12 in base 5, also known as Lumo Cora, multiplied by 3 in base 5 or Nexo. For the first step, we multiply Nexo and Cora, which is 3 times 2 equals 6 in base 10. However, 6 in base 5 is equals to 11, also known as Lumo Lumo. Since we have 11, we write down 1 and carry over 1. For the next step, we also multiply Nexo and Lumo together, which is equals to 3 or Nexo in base 5. Then, we add the amount that we carried over, which is 1, giving us the value of 4 or Sura. So, in the Numbeks system, Lumo Cora multiplied by Nexo is equals to Sura Lumo. For our second example, we have 4 in base 5, also called as Sura, multiplied by 3 again or Nexo in the Numbeks system. In the base 10 system, 4 times 3 is equals to 12. However, for the Numbeks system, Sura times Nexo is equals to Cora Cora or 22 in base 5.
Next is division. In our number system, we use a simple method called continuous subtraction to perform division. So, for example, to divide Lumo Sura or 14 by Sura, we start with Lumo Sura and keep subtracting Sura from it. First, we subtract Sura from Lumo Sura, which gives us Lumo Nava or 10. So, we do it a second time, subtracting Sura from Lumo Nava, which leaves us with 1. Since 1 or Lumo is smaller than Sura, we stop. The final answer is Kora or 2 because we were able to subtract Sura 2 times and we are left with the remainder of Lumo, which is the final number left after all subtractions. This shows that division can be as simple as repeated subtraction. To check if our quotient is correct, we use the formula divisor multiplied by quotient plus remainder equals dividend. In our problem, divisor is Sura, the quotient is Kora, and the remainder is Lumo. So to check the answer, we multiply the Sura by Kora, then add Lumo. Since 4 times 2 is equal to 8, and 8 is equivalent to Lumo Nexo, or 13 in our system, we add the remainder Lumo to get 14. So this matches our original dividend Lumo Sura, so our answer is correct. So here is another example. In the given problem, we are dividing 12, which is called Lumo Kora, by 3, which is called Nexo. To solve this, we can think of division as repeated subtraction. Starting with Lumo Kora, we subtract Nexo again and again until we reach 0. The first subtraction gives us Lumo Nexo, or 14. The second gives Lumo Lumo, or 11. The third gives Kora Lumo, or 3. And finally, subtracting Nexo one more time brings us to 0. Since we are able to subtract Nexo exactly 4 times, the quotient is 4, which is called Sura. Thus, Lumo minus Kora divided by Nexo is equal to Sura. Next is our very own Numbeks calendar. So we have here our calendar. Our calendar is built on a custom-based 5 numeration system. To express date using the symbolic language, we first convert standard calendar months into their base 5 equivalents. For example, August, it is the 8th month, which becomes 13, which we call Lumo Nexo in base 5. So to understand how the calendar works, let's walk through a date calculation. So suppose we want to find the date 10 days after August 27, 2025. The first thing that we need is to convert 27 from base 10 to base 5. So 27 becomes 102 or Lumo Nava Kora. Then add 10, which gives us 37 in base 10, which converts to 122 or Lumo Kora Kora. Since August has 31 days, which is 111 or Lumo Lumo Lumo, we check if our new date exceeds that. So it does because 122 is greater than 111. So we need to subtract to find how far to the next month we've gone. 122 minus 111 is equal to 11 or Lumo Lumo. That means we're 11 days into the next month. So September, the 9th month, becomes 14 or Lumo Sura in base 5. So the final date is month Lumo Sura, day Lumo Lumo, which corresponds to September 6 in the standard calendar. Next is our very own Numbeks clock. This clock is a visual embodiment of our Numbeks block system, reimagined in a circular format inspired by traditional timekeeping. Rather than using standard Arabic numerals, it features symbolic hybrid digits drawn from tarot iconography, reflecting the Numbeks philosophy that numbers are not merely quantities, they are meaningful, expressive symbols. This symbolic clock mirrors that approach by replacing conventional numerals with visually distinctive symbols rooted in tarot tradition. Each position on the clock face corresponds to a symbolic value arranged clockwise to preserve the familiar rhythm of time while inviting learners to interpret it through a symbolic lens. Lastly, here is our reflection in designing our system, Numbeks.
The challenging about designing the system, one challenge we faced was creating a symbol that were both meaningful and easy to recognize. We wanted each symbol to reflect something important to the Filipino LGBTQ+ community, but also be simple enough to read and use. It took time and teamwork to design symbols that balance creativity, clarity, and cultural meaning.
What are the advantages and disadvantages of the system? An advantage is that the number system allows the community to express themselves uniquely and creatively, helping build connection and identify. A disadvantages is that people outside the community might find it confusing or hard to follow. 3. What did we learn about numeration system? We learned that numeration system are not just for counting. They carry cultural meanings and be adapted for different groups. Numbers can be used creatively to express, identify, and communicate in new ways.